Okay, so in the last video, we talked about solving by elimination, either by adding the two equations or subtracting the two equations so that we had opposite coefficients and that would cancel out one of the variables, okay? For instance, in this guy, when we were looking at this example here, let's see if I can get a smaller eraser. There we go. When we were looking at this guy here, we found the opposite coefficients, a positive 5y and a negative 5y, okay? So when we added those together, that canceled out, and we only had x to solve for. Then we were able to plug in what we found for x into one of the original equations in order to solve for y. Then we ran into a situation down here in which we said, these guys right here, this positive 6 and this positive 6, they're close to opposite coefficients, but they're both positive. So when that was the case, we subtracted the two equations instead. That way we had those opposite coefficients to cancel out. Now, I also want to point out here, when we're subtracting these two, another way we could think of it, that's really multiplying one of those by a -1 and then adding the two together. Okay, so I want to kind of revisit this this question here, this system of linear equations, and look at it from a different point of view. Okay, so let's see if we can get to the same answer for 6 going a new approach. Okay, now just like I talked about a second ago, when we subtract, we can think of that as really multiplying by a negative and then adding the two together. Okay, so if I multiply the bottom here by a -1, if I multiply the positive 6 by a -1, that's going to give me -6x. Well, notice that now gives me opposite coefficients. I now have a positive 6 and a -6, okay? So when we add the two together, the x values will cancel out. But the problem is I can't just do that to one of the terms. I have to do that to each term. So we're going to multiply a -1 to each term and then add the top equation and the bottom equation together. So multiplying a -1 to 6x gives me a negative 6x. Multiplying -1 to a -7y gives me a positive 7y. And then multiplying -1 to a -18 gives us a positive 18. So this essentially becomes our new equation, and now we can add the top and the bottom together. Well, adding 6x and -6x, those guys cancel out. -8y and positive 7y, different signs, so we subtract, and we're going to get 1y. 8's bigger and it's negative, so we get -1y, or you could just say -y, either way. And then adding -24 and 18, again, different sign, we subtract, so we're going to get 6. 24 is bigger and it's negative, so we get -6. Now we have to get rid of the coefficient of y, which is a -1, dividing by a -1 to both sides. We get y is equal to negative and negative make positive. 6 over 1 gives us 6. So we find that the y value is 6. Well, notice that's what we found last time. Okay. Then after that, we have to take 6 and plug it back into one of the original equations. Well, we still have the work left up from last time. Notice that's what we did in the last video, is we took 6, plugged it back in for y, and found that we got x equals 4. So we're going to get the same solution going this new approach, okay? Now that's the approach we want to take with examples like this, where it's not so obvious in terms of we don't have a opposite coefficient already given to us or anything that remotely looks like an opposite coefficients, okay? So we want to be able to multiply either the top equation or the bottom equation by some constant to create opposite coefficients and then add the two together. Okay, so when we look at number 5 here, if I look at the x values, -5x and positive 7x, is there some constant you can think of that I can multiply to a -5 or to 7 that would make it so that those guys are opposite coefficients? Nothing's really coming to mind, right? However, let's go over to the y's. Is there something I can multiply one of those by to create opposite coefficients? Well, what about the positive y? Couldn't I just multiply that by 5? If I multiply 5 to y, that gives me a positive 5y, right? Well, that would be opposite coefficients with a -5y, okay? So what we need to do is multiply the top equation by a positive 5, and that will create opposite coefficients for our y's, okay? So we're going to go back to this top equation here, and we're going to multiply each term by a positive 5. So 5 times the -5x gives me a -25x. 5 times y gives me positive 5y. And 5 times a negative 4 is going to give me negative 20. Now, in this new equation, I now have opposite coefficients, a positive 5y and a negative 5y. Now we can add these together like we did in the last video. I have a negative 25x, and I'm going to add that to 7. Again, we have different signs, so we're going to subtract and get 18, but the larger value is negative. Our opposites cancel out, and then we have a negative 20 and a positive 20. Well, those are opposites too, but we need a constant on the other side so we can solve. So that's going to give us a negative 20 and a positive 20, 0. Okay? Well, getting rid of our coefficient here, dividing negative 18 from both sides. This goes away and we get x equals 0 divided by anything is 0. So our x value is going to be 0. Now we need to plug this back in into one of the original equations. Well, let's plug it back into the second one, since that's the one that we didn't mark out, and plug that in for the x value, okay? So we have 7 times 0 minus 5y equals 20. 7 times 0 is 0, and then we have a negative 5y equals 20. Now, this turns into a two-step. Notice we really don't have to write the 0, but if it helps you, we can leave it there and treat it like a two-step, in which case we would subtract 0 over, and we'd have a negative 5y equals 20 minus 0 is 20. Now again, you don't have to put the 0 there, but if it helps, treat it like a two-step, subtract it over, and then we got to divide by our coefficient here, and we get y equals positive and negative make a negative. 20 divided by 5 is 4. So our solution here would be 0, negative 4. Okay? So that's that guy. Let's try one more. Okay? If we look at number 6 here, do you see anything that remotely looks like an opposite coefficient? Maybe not right away, but is there some value I can multiply the top or the bottom by to create an opposite coefficient? Well, notice if I multiply this 7 by a 2, that's going to give me 14. That's pretty close. That would give me a 14x. That's pretty close. What could I change this by just a little bit so that it creates an opposite coefficient? Well, instead of 2, what about negative 2? If I multiply this by negative 2, isn't that going to give me a negative 14? Yeah, now I have opposite coefficients here. So we're going to multiply the bottom by a negative 2 to each term. So on the bottom one, we have a negative 14, then a negative 2 times a negative 4y. 2 negatives make a positive. 2 times 4 is 8, so we get 8y. And then negative 2 times 2, negative and a positive make a negative. 2 times 2 is 4. So this becomes our new equation, and now we just need to add everything together. Well, 14x plus a negative 14x, those guys cancel out. Negative 5y plus 8y gives us 3y. And negative 8 plus negative 4, same sign, add and keep the sign, keeping the sign which is negative, and we get negative 12. Divide by our coefficient here, and we get y equals negative 4. Okay? Last step we need here is plug it back in. Well, let's plug it back into the one that we didn't scratch out, and let's plug it back in for our y. Okay? I'm kind of running out of room, so I'll write it below. So we have 14x minus 5 times a negative 4 for our y equals negative 8. Solving for this, a negative 5 and a negative 4 is going to give me a positive 20. Two-step equation, what do we do first? Subtract 20 over, and we get 14x is equal to, same sign, add and keep the sign, 20 and 8 make 28, and they're both negative. Divide by the coefficient to both sides, and we get x equals 28 divided by 14 is 2. Negative and positive make negative. So our solution here would be a negative 2 for the x and negative 4 for the y. Okay? So that's how we're going to solve elimination by multiplying by a constant first and then creating our opposite coefficients. Okay?